Alright, today we're going to be working on a section 5 of chapter 2, which is about literal equations and formulas. And our objective of today is to be able to rewrite and identify literal equations and basically just solve for one variable in an equation. Now, your first question might be, what exactly is a literal equation? That might be a term that we're not so familiar with. Literal equations are basically any equation that involves two or more variables. So 10x plus 5y equals 80 would be a good example of a literal equation because there's both an x and a y. Once we get into linear graphing and linear functions and that sort of thing, we're going to deal a lot with these literal equations. So they're pretty important. Okay, and what we'll do today is practice isolating for either just the x or just the y and rewriting this formula or this equation in a different way. Now, the process that we're going to go through, okay, when we are trying to isolate y, okay, let's say that we're trying to solve this equation for y. Okay, the process is pretty simple. Number one, add or subtract your x's on both sides of the equation so that we can cancel them out. Alright, we need x and y separated. We need y on one side and x on the other. So in this case, with 10x plus 5y equals 80, since we've got a positive 10x, we're going to just subtract 10x. And subtract 10x from the other side. Again, all we're doing is rewriting this equation. Now, since these cancel off, we are left with just 5y is equal to either 80 minus 10x or negative 10x plus 80. I'm going to say 80 minus 10x. 10x. Okay? The second step is to divide by the coefficient of y. And remember, the term coefficient means the number that is multiplying by y. So in this case, it is 5. And since we are simplifying this, we're going to divide both sides of the equation by 5 to cancel off our multiplying by 5. Okay, these will cancel. And if we divide each of these terms by 5, we should get y equals 80 over 5, or 80 divided by 5, which I believe gets us to 16. And minus 10 divided by 5 is just 2x. Okay, so all we did here is we divided this whole thing by 5. Alright, so now all we've done again is rewritten 10x plus 5y into y equals 16 minus 10x, or 2x. Okay, so this would be our rewritten answer. Y equals 16 minus 2x. Now, if we're going to use this information, right, let's say that we were given that, we figured out that y is equal to 16 minus 10x, or 2x, excuse me. Use the new equation to find y when x is equal to 3 and x is equal to 6. All we would do then is take y equals 16 minus 2 times some value, right? And since we're evaluating it when x is equal to 3 and x is equal to 6, all we do is plug 3 into the equation. From there, it just turns into an order of operations problem. Y equals 16 minus 2 times 3, which is 6. Y would equal 16 minus 6, or 10. Okay, so when x is 3, y is equal to 10. And when x is 6, again, this is the same process, only instead of a 3 in there, we're plugging in a 6. So let's say instead of a 3, we had, we'll extend this, 16 minus 2 times 6. 16 minus 2 times 6, which is 12. 16 minus 12 equals 4. Okay? So when x is 6, y is equal to 4. Okay? Let's take a look at another example of this. All right? Practice says solve the equation 4 equals 2m minus 5n for m. So since we're solving for m, we want to get this m all by itself. Right, 4 equals 2m minus 5n. So what we're going to do first, we're trying to isolate m. We've got 2m minus 5n. The opposite of a subtraction of 5n is just adding 5n. These two can cancel. And whatever we do to one side, we got to do to the other. Remember to always show our work. 4 minus 5n is equal to 2m. Alright? Now, from there, we've got 2 times a number. 2 times m is equal to 4 minus 5n. All we need to do is divide each term by 2. And since this one will give us kind of a decimal or a fraction, what I'm going to do is just rewrite this like so. Oops, let's go up. We're just going to write this, since these cancel off, m is equal to 4 minus 5n divided by 2. So then whatever value we plug in for n, we're just going to take, let's say if n was 1, we take 4 minus 5 times 1, which is 4 minus 5, negative 1 over 2 is equal to m. Okay. Let's have one more example and then we'll call it a day. Alright, y equals, or solve for y, then find the value of y when x is equal to 4. Okay, again, our first step, we need to add or subtract to get all of our x's or our opposite variables on the other side of the equal sign. Okay, so in this case, we're going to subtract 6x. Subtract 6x. And rewrite. 3y is equal to 12 minus 6x. And now notice, if we were to add the opposite, this could be written as negative 6x plus 12 too. It's kind of up to you. It's up to your preference, what you'd rather do. Okay? And 3y equals 12 minus 6x. Again, this is what 3 times y is equal to, so if we want to figure out what just y is equal to, we need to divide by 3, and divide each term by 3. Since 12 and 6 will both have a factor of 3, or you can divide it by 3 evenly, we can simplify this down to a nice equation. Y is going to be equal to 12 divided by 3, which is 4, and 6 divided by 3 minus 2x. 4 minus 2x. Now the second step, again, there's a two-step problem. Evaluate or find the value of y when x is equal to 4. All we do is substitute 4 in for our x. So we should get y is equal to 4 minus 2 times 4, or y is equal to 4 minus 8. Y will be equal to a negative 4. Okay, so this is all for today. I hope this has helped, and we'll talk about it in class a little bit more. Thanks.